So, guys, let's do 17,131. Go ahead and do the figure. I'll do the figure on my side. And then we start doing the solution together. So, 17,131. Okay, so as you do the figure, think about if something is moving relative or not. So the distance between 2 points is fixed or it's not fixed. Then what is the role of that bar over there? Okay, so it's probably doing something, no? Okay. Here, my figure is not that good, but doesn't matter. Oops. Okay, it's also a color here. So if they say the velocity is constant, what does that mean about the acceleration? 0, perfect. Something I like about this problem is that they give you, instead of giving you the coordinates, they give you the angle, which I'm not too crazy about it, but what can I do? So let's see, determine the angular acceleration of AC. And the relative velocity of BB relative, whatever that is, the one is too far. So that's the figure that I have. Okay, so what is the strategy all the time? Is to try to find the velocity of one point from two different locations, correct? So first, do we know the velocity of a point over here? What is VA? Okay, but and then the bar indicates what? That it's only going to be on the y direction, no? Yeah? So we know everything. So now the strategy will be to find the velocity of the same point from a different location. We can find it from which location? All right, there's not that many points, huh? Okay, we can find it from point B. So we can write now, is the distance between A and B fixed? So what does that mean? So we're going to have the relative term showing up. So we're going to have VA equal to VB plus velocity of A with respect to B plus omega of which bar? AC, BC, BA, whatever you want is the same bar, no? I use AC because it asks us for alpha AC cross S of what? A with respect to B. Do we know VB? Okay, so we're gonna have now. Okay, what do we know about velocity of A with respect to B? We don't know the magnitude, but do we know the direction? Okay, so what will be the direction? We don't know if it's go up or down, it doesn't matter, but if so will be yeah, cosine 30 sine 30, or you could put negative cosine 30, negative sine 30 if you assume it's going down, no? You understand this step? Magnitude, direction, no? Okay? Plus ijk 0, 0 omega AC. And L is 1, so that's why it simplifies everything. What is the position of A with respect to B? What will be the X? L cos 30, I put the is 1, no, you agree, but I just put that you see that it's not this unit vector, L sine 30 and 0. So basically from here we're gonna get the equation. Okay, so let's do it. This will equal to V1. So how much is cosine 30? All right, so 0.8667. 0.8666.
0.866.
Okay, so it's fine. 667. Okay, we can live with that. Velocity of A with respect to B, and then we're gonna have what? 1/2. Sine 30 should be 1/2 omega AC. Now here we're gonna have 1/2 velocity of A with respect to B plus the 8.8667 omega AC. So that is going to give us what? That equation. What is the next step? Okay, perfect. I mean, you see the steps are the same, no? So now what do we get? We're gonna get the two equations, 0.8667 velocity of A with respect to B minus 0.5 omega AC will be equal to 0. And then we have 0.5 velocity of A with respect to B plus 0.8667 omega AC equal to 10. So I'll let you go and solve for omega AC. The magnitude of velocity of A with respect to B. So it would be good if we do the problem together, so you do the calculations. That way it gives you time to think about the problem. Okay, so I forgot to resume. So you did the calculation, you found this for the angular velocity and relative acceleration, relative velocity. We did the same process. Since the velocity is constant, we know the acceleration of point A will be 0. Then we write down all the terms with the relative term. We do the algebra term by term. We go to the equations, and now you are solving. What do you find for alpha IC?
I thought the acceleration area is first.
Okay, that's fine.
I got 125.04.
Somebody can double check. So after you do the calculation, we agree on the negative 86.5. They don't ask for the relative acceleration of A with respect to B, but you can see you can also get it from this equation, no? All right. So basically, in this problem, the two answers were this one over here and this one over here. That's the two things they were asking us. Okay, so before we do 17139, let's do a little math review, okay? Like we did last time, remember we did one that a vector has magnitude and direction, no? And you can find the direction vector. So let's do here another short math review. I'm not that sure how I'm going to present this, but let's do it. So let's say we have a vector u with coordinates. Let's just do it 2D, AB, and a vector v. With coordinates CD. Okay, so what is the definition of the dot product?
A times C plus B times B.
Okay, I agree with you. Perfect. But then what is the real definition here? This would be magnitude of
Magnitude of U times
UV times what? Cos theta, no? This is, let's say this is U and this is V. It will be cos theta, no? Okay, so as you mentioned over here, so if U is perpendicular to V, then what's going to happen to the dot product?
No, it will
Yeah, cosine 90 is 0, no? Okay, it will be 0. So one way to find then the perpendicular vector will be to look at the dot product and make sure that it's equal to 0. Okay, so here I don't know how to present this. So okay, so let's see, U dot V is equal to what? So will be, oh, first thing, good question since you mentioned this. The dot product, does it give you a vector or does it give you a scalar? Scalar, perfect. So that's what I want to do here. So basically we're gonna get over here, we do this, we're gonna get AC plus BD. So there's two ways for this to be perpendicular, no? Okay, so I don't know how to write this, read to the truth. So if U and V are perpendicular, then we have two choices. We can have, so let's say V is perpendicular to A. What can we have? V can be equal to what? What will you do here? You do A times, so this could be equal to what? The D, so the C could be equal to what? Or, I mean, you could have here, let's say B, so C can be equal to B, no? Yeah? And this could be equal to what? Negative A? Correct? And then you will have 0, no?
Right.
That makes sense? Or you could have what? V equal to negative B or A. So basically the only thing I'm saying here is that if you have here, if this is U over here, oops, U, you can be perpendicular going in that direction, or you can be perpendicular going in that direction, no? That's basically what these two vectors are. I know you have done that before, but maybe again a review is good. So if you know the coordinates of a vector, you can find rapidly what is a perpendicular vector to it. Yes? You switch and you flip, you flip them and you switch one of the signs, no? Depending if you want to go up or down. Right? Yes?
I think I'm having a hard time visualizing where, is that
C we can do replaced by B. I'm not sure how to get out of it.
Okay, so this is V. So the coordinates of V generally are C or D. So let's say in the first case, if you replace C by B and D by minus A, and go and substitute into these equations, what do you get? A times B, correct? Plus B times minus A. So that will give you 0. Does that make sense? I mean, the application of this, if you want me to let you know, is that on the problem, for example, of the board is that, let's say, you know, this would be the application you will be doing in that problem. Let's say you know the direction of the radius, and you need to find the velocity. Do you know the velocity of the acceleration will be perpendicular, no? Yes? So if you know the direction of this vector, you're going to be able to find the direction of this one pretty quick. That's going to be the application. Does that make sense or no? Do you understand the way it's going to be done mathematically? This is the time to ask the questions. Okay, that's going to be the application. Okay? Okay? All right, let's go then. Now we're going to go to see that problem. That's probably one of the most difficult, if not the most difficult, the one you want to do, okay? These are the ones, I guess. So, the disk rolls on the plane, so do the figure. With a constant counterclockwise angular velocity of 10 radians per second. So that's good. So that means that the angular acceleration of the disk will be 0, no? All right, so let's do the figure. Fit 45 degrees. What else do we know? Omega disk is 10 radians per second. It's constant. So that means that the angular acceleration of the disk is going to be equal to 0. Determine the angular acceleration of alpha AB. And we know the diameter of the disk, the radius of the disk. Is 1 foot. So you see, the bad thing about the assignments using the online is that they don't have the difficult problems. They only have the stuff that is direct application. So I need to do all this stuff with you guys, okay? Okay, so the procedure doesn't change at all. All right, everything is the same. What makes this problem difficult is the visualization, okay? All right, but we'll figure it out. Okay, so again, so you start this problem. Probably we're going to do another figure, but we're going to start from here. So what is something you maybe should start right away? There is a disk. So what does that mean? It is a disk rolling.
It's going
to be some type of instantaneous center. Where is going to be the instantaneous center? Right over here. And I don't know why. I always call it point P. No? But this is an instantaneous center. Okay? Now, before finding the acceleration, what do we need to do? We need to go and solve for the velocities, no? Yes? Okay? So let's see. So we can find the velocity of which point from which two locations. Okay, we can find position of A from B and from P. It's always a point of contact between two different rigid bodies, no? So let's first find the velocity of A. Let's do the easy way. They're both not that complicated, but let's say the velocity of A first from point B. Is the distance between B and A constant? Correct. So we can write VB plus omega AB cross S of A with respect to B. All right. What is VB? 0. So we can write over here I, J, K, 0, 0, omega AB. And here, maybe we need to be, again, trigonometry, like we had on one problem. All right, let's go trigonometry, basic trigonometry, but we did that already in a problem, no? The one of the bar rolling, I think we have to do it. So this is 2. What is that distance over here? The height over here? So will be whatever, 1 time square root of 2 over 2, no?
2. So it's 7.71.
Okay, do the calculations, and can you do the calculation for this one? You do 2 square plus, you do the square root of 2 square plus that value there square. What do you get for this one? Yeah, so 4 minus the square root of this one, you take the square root.
1.87.
1.87? All right, I'll trust you. Yes? I know, you are doing the calculations.
Square root of 4 minus 771 square. Right?
So 2 square minus this one square, and you take the square root of that. Okay, calculations are on you, huh? All right. So, what is, okay. So basically now what is the position of A with respect to B?
1.8 negative.
Negative 1.87, you say, no?
Yes.
Okay. And then this will be square root of 2 over 2 and 0. So this will give you the first expression for the A equal to, so how much is square root of 2 divided by 2? 0.
Negative 0.7071.
That is 0.701. I mean, do you take your calculator?
It would be positive, but because it's active.
Okay. Omega, and this will be negative 1.87 omega of A with respect to B. Take your, what is it?
771.
Instead of the 0.7, oh. Good. Let me put the 7 over here. 707. Okay. Okay, I know the two signs are negative because if you think about it, if this is rotating, let's see if that makes sense or not. Okay. 1. So if this is rotating, from point B, or let's see, we don't know what is omega B, so, but we know that here, we'll see what happens next, okay? Forget about that figure for now. Don't do it now, okay? So now the next thing we need to do is the velocity of A from where? From P. Okay. So now, do you remember we say you need oh, okay. I think I did it reverse here. Yeah, I think here. Yeah, I think here I did it wrong. Okay, I wasn't thinking too much.
The distance between A and B is not.
Correct. No, we do it right. So I think it just said exactly the right thing. So is the constant between P and C always going to be the same? No. Yeah, we agree that it's not going to be the same, no? So what does that mean? We're going to have relative terms. We're going to have, so we don't think too much about it. We have Vp plus what? Relative velocity of A with respect to P plus, now we're talking about the disk cross S of A with respect to P. Okay? All right. So, what is the definition? Oh, just wait. So, here we are. So, velocity of P equal to 0 by definition. Okay? Next, over here, we're going to have the A, again, will be equal to the magnitude of A with respect to P times A. Let me just call this one E, okay? Don't worry about too much. E. So magnitude direction, no? All right. Plus, here I'm going to put this term over here, I, J, K, 0, 0. What is omega? 10. And here again, some basic trigonometry, but let's be careful. What would be the distance of A with respect to P? What would be the X?
0.707.
So 0.707.
And 1.7.
So would be this, would be the same as this one here, no? Correct? Yes? But for the Y will be the radius plus that height, no? So it will be 1 plus 1 square root of 2 of sine 45. Yes? So 1.707 and 0. Okay? So I'm waiting for the E hat, okay? The A would be equal to velocity of A with respect to P, E hat, plus whatever, the minus 17.07 and 7 point
Isn't it 1.727? Oh, times 10.
times 10. We have this. Okay, so for now. So now maybe we can go to that little figure I did over here. That way we can use it. Okay, because there is the disk. Remember before we had bars that was forcing the motion in one direction, no? So the velocity of A here is going to be in one direction. Either going up or going down, no? But it needs to be perpendicular to that distance over here, to the radius. Yes? Yes?
Yeah.
Okay, so this over here, and upload it this way, will be velocity of A with respect to P. All right, so now, okay. All right, let me do another figure here. The same figure, but again, over here. Okay, so maybe let's change the notation part over here, the perpendicular. And we're gonna call this one here E hat. So what would be, and if you want to call the center of the disk, let's call it O, okay? So what would be that vector? What would be E? This vector would be equal to what? What would be this unit vector? Would be cos 45, sin 45. Correct? Okay? Now, if we plot it this way, you can do it on the opposite direction, but let's call this one our E perpendicular. If we follow the rule that we said before, how can we find this perpendicular vector? What do we need to do? We're going to switch. That's automatically. Then to know if we have this one, which one do we need to put negative? The X or the Y? The X, correct. If I have plotted this one going in the opposite direction, which one will you switch? The Y, no? Did you see how that happened here? Okay, so this one, if you want, will be now negative 0.707, and this will be 0.707. So now I'm just going to go and substitute this E perpendicular into this equation. All right? Okay, because the vector of A with respect to P is in that this is the magnitude and it's in this direction. Remember, this has to go on top of the disk, no? There is no other way that velocity can be. Yeah, it's either going to be in that direction, no? It needs to be perpendicular to that point, no? Okay, so I just rewrite that equation here. The A equals to velocity of A with respect to P, nearly 0.707, 0.707, plus minus 17.07, 7.07. So this is going to give us a second expression, velocity of A equal to negative 0.707 velocity of A with respect to P, minus 17.07, and 0.707 velocity of A with respect to P, plus 7.07. So this will be our expression 2. So you see the procedure doesn't change, but the understanding becomes more complex, no? Yes?
I have a little bit still trying to figure out for the direction, perpendicular direction, why our choice for the negative.
Okay. If you only look at this vector, okay, at this vector here, the E perpendicular, correct? What is the X component is positive or negative? And the Y component? Okay, so that's what we got over here.
It's a simple fact. So if it was the other way, it would be positive.
Correct. Okay, no, good question. Okay, so what is the next step on the procedure? So you see the procedure doesn't change at all, no? One and two. So we're gonna have negative 0.707 omega AB will be equal to negative 0.707. Oh, this is going to be easier to solve this one. Velocity of A with respect to P minus 17.07 and negative 1.87 omega of A with respect to B will be equal to 0.707 velocity of A with respect to P plus 7.07. So this one you can solve pretty quick. What can you do? If you add them together, you can solve right away for omega b, no? So you will say, or you will find whatever. So you add them together, solve. But omega b should be very quick. So it's 3.88. Okay. It's 10 divided by 1.7. No? Okay, and what would be the relative velocity of A with respect to P? Sorry, the magnitude? Somebody can double check, please. Negative 20.26. And this is feet per second, okay? So basically that means that the vector velocity of A with respect to P will be equal to, what is 20.26 times 0.707? 14.33. So the first one, what's going to happen? Is going to be positive, no? Because it goes negative times negative, no? For the E perpendicular. And the second one will be then negative minus 14.33. So what does that mean? What is that indicating? Is that really this one is going down, no? Yeah? Yeah. But if we assume going down, then we'll have the whatever, the reverse values over here. So it doesn't matter which direction you select. Okay, so here we go. Any questions so far? Now the acceleration is the one that is fun. So for the acceleration, we do exactly the same thing. Let's do first the easy one, which is to find the acceleration of A from which point? From point B, no? And the distance between A and B is always the same. Acceleration of A equal acceleration of B plus alpha AB cross S of A with respect to B minus omega square AB S of A with respect to B. Now you should know these equations. What is that one? What is the acceleration of B? 0, so you can write over here I, J, K, 0, 0, alpha, AB. And we can go from before, what is the position of A with respect to B? We can get those values from the problem before. What did I do here? So did I put negative 1.87, no? Negative 1.87 and 0.707 and 0. Okay. Minus, so again, now the omega B that we just calculated is 3.88 squared times the negative 1.87 times 0.707. So you're gonna have to do those calculations for me, but the first expression we're gonna have for A sub A will be negative 0.707 alpha AB plus a value yeah. Okay, that sounds good because that's about whatever 3.88 squared is about 15 something times 2. Yeah. 28.15.
Yeah, I remember that.
I mean, like I said, it's practice, okay? I know you know how to do it. 28.15. And this one would be 3.88 squared times 0.707.
10.64.
10.64. Okay, so you see that it's easy to make numerical errors. If you don't practice, don't expect to do it properly the day of the exam. Guarantee, okay, 100%. Zero doubt that if you don't practice in class, magically the day of the exam is not going to work. Okay. Now we need to do find the acceleration of A from point B. So on this one, this is going to get interesting, as you said. Yeah. So, acceleration of A from point B. So let's not think too much about when we write the equation. We have acceleration of P plus relative acceleration of A with respect to P plus alpha, how do we call it, D?
Yes.
Yeah, D, no? Yeah, alpha D cross S of A with respect to P minus omega squared P S of A with respect to P plus 2 times omega disk times V of A with respect to P. Let's just say, so what is, okay, here we go. This one has it all, huh?
Yeah.
Yeah, this problem has it all.
It's so confusing in terms of the radius time.
Yeah, so basically this term, okay, so no, I mean, and that's not even, I mean, this is the new term, okay? So let's look at this term over here, okay? And then this one and this one, I hope you kind of right now know what is happening, no? Between those two terms, okay? But this is the new one, which is going to be interesting. So term acceleration of A with respect to P. So this is the relative acceleration of A with respect to P. Correct? But you can break the acceleration into how many terms? 2. Good. You can break this one into, let's say, an acceleration of A with respect to P. That will be the tangent term, no? And you could break this one also on the term acceleration of A with respect to P, normal or centripetal. Whoa. So really that adds 2 more terms to the equation. Okay, so let's put over here term acceleration of A with respect to P is going to give 2 terms. To P normal. Okay, this one over here What is the normal expression for the tangential term? What is it?
The exertion
Alpha cross S, no?
S, yeah. Alpha AP plus S.
Yeah, but in this case, this is rotating with respect to which point? So it will be alpha cross or alpha of the disk S. This is rotating with respect to which point? From the center, no? So it will be position of whatever, A with respect to O, no? Okay, now this term is the one that becomes interesting. So V let me look, hold on one second, because I think there's two ways to do this. Okay, guys, so here pay attention, okay? As I'll pause it for a second. So we just said that these relative terms, because it's the acceleration, is gonna have, we know it's gonna be at this point, and we know it's gonna have one tangential component, correct? And we also know that it's gonna have a centripetal component, okay? So I break this one into two terms. So the first one would be alpha cross, so delta, alpha cross S of A with respect to P. That would be whatever is alpha cross, we do that later, okay? In a second. Now, let's look at this term over here. And maybe I modified this one, but for this one, let's modify it this way. So now the normal acceleration, we know is, by definition, should be minus omega square R, no? Okay, but here, the only thing I'm looking at, you see I didn't put a bar on top, which means what? If I don't put a bar, I'm just looking at the magnitude, no? So what I'm seeing over here is that I know the magnitude of the velocity of A is omega cross R, so I can rewrite the angular velocity equal to the V divided by R, okay? The same thing, I know the magnitude of this one, of the normal acceleration, which would be this with this term over here, okay, will be equal to omega squared times R. I can substitute the omega by V squared over R, and now have all this term over here will be V squared over R. Magnitude, no? Okay, so if you want here, this term over here, I could rewrite it as magnitude of A with respect to P squared divided by R times what? What do you know about this term? This is the magnitude, but what will be the direction? Will be just E, no? Correct? And then maybe we need to do something because we took the E going up or going down, whatever. We will have to put a value here, no? If it's up and down. Okay. Okay, so here we need to be careful, okay? When we take this one here, this vector here, okay? Before, I think we selected to take it in that direction, correct? Okay, so if you take it in that direction, really the centripetal acceleration should go what? Should go towards the inside of the motion, no? So if we take it this way, what should we add over here? A negative sign. So you see, there's a lot of little things that come into play. Okay, now this term is equal to this, but also as well, what can we say about this term? Now this term should be equal to what? It's over here. Okay, it's this term over here, no? we can say that we don't know the magnitude, but do we know the direction? Which would be what? The E perpendicular. And that will replace the cross product. All right, so let's see how can we do this. So, okay, so what does that mean? So that means that replacing or substituting back, so replacing into above equation is going to give us what? Acceleration of A will be equal to acceleration of P plus what? The two terms we have over here, so acceleration of A with respect to P perpendicular, so this is the two terms, minus the V of A with respect to P square divided by R times E plus alpha disk cross S of A with respect to P. Now this one, I'm going to be very careful here, minus omega squared P. Here, I'm going to write it under this form, just to make sure something is clear. What is the position of A with respect to P? We had it before, and that was equal to 0.707, and then 1 plus 0.707. Yes? Okay, maybe you know where I'm going now, no? Hold on, let me finish the other line. And now the last term will be plus 2 times omega d cross V of A with respect to P. All right, now remember, maybe I don't want to put too much on the same figure, but this term over here is going to cancel which term? Only the term from here to the ground to the center. Yes? So that means that this term over here is only going to cancel this one. It's 0.707 and 0.707. Okay? So now in this equation over here, okay, velocity of A with respect to B to P is known. We just solved it before. Yes?
Yes.
Okay? Was 20.2, negative 20.26. R, we know is equal to 1. Okay? We know the E perpendicular and the E, no? Okay? So if you want, let's write over here. Velocity of A with respect to P is known is negative 20.26. Then we know that R is 1, no? Okay? E perpendicular, we say we're going to take what? Let's look at the previous pages. E perpendicular is negative 0.707, 0.707. E no perpendicular is equal to what? 0.707, 0.707. So basically, everything is known. What are the two unknowns? Wait, so what was the other question? Do we find? I completely got lost now. So if we equate,
Yeah, we have A and B. So we have equation 3 and
yeah, but what is the equation 3? I lost it. That's why on my pages. Okay. Question 3, I completely lost it, so here it is, okay? So equating, so let's put over here. Equating 3 and 4. Okay? We only have 2 unknowns. Okay, I'll put over here. The omega p was given, no? What was it, 10? Omega, I'll call it D instead of P, disk, D. Sorry, this is D. Yeah, I don't know what I call it. This is D. So this should be 10. So basically, if you equate those 2 equations, what will be the 2 unknowns?
Alpha A.
Correct. Alpha, the disk, did I call it AP? Alpha of the disk and alpha AB, no?
Alpha C and A acceleration.
The alpha of the, okay, the alpha of the disk is 0, correct, and we don't know the relative acceleration of A with respect to P. You're absolutely right, okay? So we solve for these 2, and since we don't have time, that's why I'm going to give you the answer. I was rushing. So I want you guys to finish this problem on your own, all right? So if we do this correct, you find over here alpha AB should be equal to 64.6 radians second squared. Okay, guys, so you see, this is probably one of the most difficult problems. Next time, we're probably do the next most difficult, that is the, I mean, we can do 141, we're going to do 141, and the one I saw before that I told you was even worse than that. Which one is it? It was further down, and I don't know. Okay, and we do another one. Does it get harder from this, or is this like the hardest of?
We're only in the 5th week. It's definitely gonna get worse.
I think the one that I stopped and I said that one is hard. I think that one might be a bit harder than this one. But this is one of the hardest ones. Number 2, I would guess. Number 2 in the hardest ones. I mean, if you understand this one, you're good. This is difficult, okay?
So since we knew alpha of the disk for the angular acceleration of the disk was 0 from the beginning, could you cancel that couple terms at the beginning?
This time, yeah. But I mean, I like to follow procedure.
Yeah.
And not to do on the answer. But yes, that would be true. All right. There is a homework for next week, but